Good evening, everyone, and welcome to the BIS. Thanks for being here. Also, thank you to everyone joining us online. Before we start tonight, a few housekeeping items. We're not planning a fire alarm tonight, but if the fire alarm does go off, we need to leave the building. We leave through the doors at the back of the room. If the fire's at the front of the building, we leave from the back, so we turn left out of the doors at the back and go through a door into a courtyard, through some gates onto the street. And the fire assembly point is the entrance to Vauxhall Park, which is about 77 paces in that direction. If the fire's at the back, we leave through the front door of the building, which is the door that you came through. I think with that, I will hand over to Robin Brand, who is a BIS Council member, and Robin will introduce our speaker tonight. So thank you, Robin.
Thank you very much, Colin, and welcome to everybody, both in the room and online, from myself. And the main reason I'm standing here is because I'm a member of the events committee who have organised this presentation this evening. So our speaker this evening is Dr. Mykhailo Andriievskyi, head of the Propulsion Department of Skyrora Limited, the company that has become the most visible symbol of the UK's push for sovereign orbital launch capability. Its responsibilities since 2017 have been to design the engines which Skyrora needs to reach space and to create a plan of how those engines would be tested. His team has developed 3 different types of engines, including a staged combustion 70 kilonewton hydrogen peroxide kerosene version. And he will talk for about 45 minutes, and we will take questions after that if we may. And we'll take questions both in the room and online alternately. And by the usual method, I mean that in the room, if you could be kind enough to wait for the microphone, not so that people in the room can hear you, but so that people online can hear your question. So we'd be grateful for that. And so it's a privilege to be able to hear about such current commercial developments within the UK. So please, could you welcome Dr. Andriievskyi.
Thank you very much. Good evening, everyone. It is a pleasure. First of all, thank you very much, Robin, for such a kind representation myself. It's a pleasure for me to present Skyrora tonight at BIS and basically to show people what we have done, what our aims are, and how we plan to achieve. So there will be 2 tasks for tonight. For me is not to forget my speech. Hopefully it won't happen. And the task for the audience is to struggle to understand my Ukrainian Scottish accent. I hope it will not be very complicated. So the first slide will be about Skyrora. So basically, Skyrora was founded back in 2017. It has become the first commercial company whose aim is to build a launch vehicle which would be delivering satellites into orbit. Our business plan was to be a launch operator, which means we are building the launch vehicle, we prepare the mission, we integrate the payload, and we conduct the launch of a vehicle. So on this slide, you can see all the rockets which has been developed or being developed at Skyrora currently. At the left side of the slide, you can see just small sounding rockets, which we developed, let's say, for the side reasons. I will explain a bit deeper what I mean in a couple of minutes. So when I started back in 2017 with Skyrora, I was a naive engineer, and I thought that the most complicated thing is basically to build rocket, to test it, to qualify it. But in fact, it appeared that the most complicated thing is to get the licenses, get the government's approval, speak with environmental agency, and to get a license to conduct the tests. That became actually a more complicated thing. So to approach that, we built 3 small sounding rockets, just solid motors, so that we could initiate that talk with the government about how to get a launch permission. And with all the surprise, we discovered that the small vehicle, which is at the very left side of the slide, and the big one, back in the day, the government treated it as the same. They didn't see any difference. And they didn't, nobody actually knew whose permission we needed. We spoke with CIA. We said, we deal with aviation, so speak to MOD. MOD said, it's a not military application, go speak to CIA. So we had that ping pong played for a few years. But anyway, it helped. So this project helped us to start as early communication with the government as we could. Also, we used these to test our onboard avionic and to check our guidance systems, tracking antennas, and so on. And at the right side of the slide, you can see two our main vehicles, Skylark L, which is our suborbital launch vehicle. It had two purposes. The first one is to cover suborbital market for research and development purpose, basically to test something in microgravity. And the second one, it was a major step and milestone for us to build a team to train ourselves before we approach to the Skyrora XL, which will be much bigger, much more expensive. And at the very right side, Skyrora XL is presented, which is orbital launch vehicle capable of delivering up to 400 kilogram into solar synchronic orbit. So a little bit more about Skyrora. Skyrora is based in Scotland. Our headquarters is at Cumbernauld. It's our manufacturing facility. Also, we built a test site, the largest test site in the UK so far for the rocket engines. And it is built a bit south from Edinburgh. So we have the manufacturing facility, we have test site. So now we just have an easy task to build a rocket. To power our vehicles, we had to develop 3 different engines. And we started from the smaller to larger. So the smallest one is our low Earth orbit engine. We call it LEO. So LEO engine is just 3.5 kilonewton of thrust, pressure fed, very simple. It operates on hydrogen peroxide and on kerosene. At the middle of the slide, it's our 30 kilonewton engine. It was designed to be our Skylark vehicle main engine. Also pressure fed, which means that the chamber pressure is provided by the high pressure in the tanks. The additional aim of a 30 kilonewton engine, it was, let's say, our preparation to the 70 kilonewton engine, which is stage combustion, turbopump fed, also hydrogen peroxide and kerosene. The 70 kilonewton engine has, despite it has a different cycle, still shares the same catalyst and the same combustion chamber as the 30 kilonewton engine. So let's say it was our, again, like the first step, second step, and before we achieved and built the main engine. What we have achieved so far, we had a launch attempt in Iceland back in 2022. It was partially successful. We still call it successful because mechanic worked fine and we had a nice liftoff. The only problem was guidance software, roughly at 1 kilometer. Our software failed to identify its position. That's why, which caused a failure mode to be initiated, which landed the vehicle in the ocean. It was the first launch, so no problem with that. It was done in the early October 2022, and we had our consolation prize. The same day we launched the rocket, the Russian Kerch bridge fell. Coincidence. Have nothing to do with that. But Currently, we are finalizing 70 kilonewton engine qualification. We have built 17 engines so far. We have had around 53 tests. On the photo, you can see 9 engines which have been built. Some of them have already been tested as part of our preparation for the Excel first stage static fire test. So in Skyrora, we decided to unify engines between the second stage and the first stage. Basically, we have the same engine. The only difference is that on the second stage, we have a larger extension nozzle to optimize it for in-space operation. But for combustion chamber, turbo pump, propellant feed system, gas generator, everything is the same. I recently had a question, why not to build 2 engines which would be more effective from the launch vehicle point of view? So I will try to answer it straight away. We wanted to make our test site smaller. Our first stage has 9 engines give us equivalent of 63 metric tons of thrust. And the problem with that was that this engine would consume around 180 kilograms of propellant per second, which would result in larger tanks on test site, which would result in larger safety radials. And there was no available location in a reasonably accessible part of Scotland, which would provide 1.2 kilometers safety radius from main public roads. That's why we thought, okay, we'll build a smaller engine, we'll use cluster on the first stage, and the same engine on the second stage, we'll qualify it only once, and we'll need much smaller test site. It has some disadvantages as well. Everything does. So now we need to test 9 engines instead of 1, which is labor consuming, but still was totally worth it because our test site ended up to be much cheaper than the one which we would need to test 63 metric ton thrust engine. One more achievement we have so far, it was third stage static fire test, which we conducted back in 2020. It operated for the full, basically we simulated the full mission of the third stage with three engine ignitions operating for 520 seconds in total, testing our propellant management device, engine and avionic. The test was successful, and our third stage is basically waiting for the first stage to be built so that we could test it in flight. By the way, during this test, few people know, but we had a small issue with the propellant management device. So anybody who is interested in space knows that in space, to push propellant in the engine, a flexible bladder is needed. Otherwise, the propellant would just stay inside of a tank. It would separate from the intake device, and it would never go in the engine. So we were pushing to increase our TRL level. We were pushing for the test with the limited budget back in the days, and the companies were quoting us something like between 200 up to £1 million to design the membrane alone. We found it unreasonable, and our engineers came up with an ingenious idea. They went to a shop, they bought a yoga ball, they cut it in shape, glue the tabs which were needed to squeeze the propellant out. We tested it, and it actually worked. So this stage was tested with yoga balls inside. And that doesn't mean that we're going to send yoga balls in space. No. When it comes to that point, we actually already have a qualified solution. So when it comes to space, we'll have fully qualified membrane, which will qualify according to ECSS standard. But back in the day, it was not worth a hassle, and the yoga ball saved us a lot of time, a lot of money, and still increased our TRL.